Are you sick of wasting hours on JavaScript bugs with endless console logs? Let's master VS Code's debugger to cut through sneaky type errors and async chaos fast. Today, we're uncovering a hidden type bug in a shopping cart app and exploring the call stack for recursive code, all with VS Code's built-in debugger. Okay, so what we've got here is just a simple example of a little shopping cart app, and we've got this input where you can see the price of this keyboard is actually a string. Now, of course, in real life, you probably wouldn't get to see all this data right in front of you, so you would have to debug and figure out what's going on here. Now, in JavaScript, the string actually coerces correctly to a number because we're using mathematical operators, but in stricter languages, this can be a real problem. Let's set up the debugger and see how we can track this down without peppering our code with messy console logs, which honestly are just going to show, you might not even notice that it's a string when you console log it out. So first up, setting up the debugger. Now, there's two ways, depending on if you're working with front-end code or back-end code. So let's get the debugger open here. And what we can do, now I've already got a configuration file set up, and as you can see, we have our different files that we're going to debug to show some different scenarios and get you familiar with what you can do in VS Code's debugger. So let's dive into how we would set this up manually. And if you clone the project, you'll see we've made an example launch.json, and this is kind of what makes that nice menu. So as you can see, we've given it a name that identifies which file we are debugging, and that is what we're seeing when we pop open this menu here. Now, if we want to debug a front-end app, there's a little more to it. So our configuration for debugging in Chrome, we need to serve our application with something like live server. And of course, make sure that our configuration is looking at the right port. Okay, now if we're just getting set up, let's say we haven't configured all this. Let's just delete this configuration. Okay, and so then now we're going to want to come back to this example launch.json. But first up, what we can do is serve our application. Okay, so I've got just a super basic HTML file here to serve app.js so that we can mimic a front-end configuration. And then of course app.js is our sample shopping cart with our string bug that we're going to track down. Okay, so let's first up, if you don't have live server, of course, go to it and go to the extensions and just search for live server. And this is just a simple way, install this is just a simple way to have a dev server for your application. Okay, I've already got that installed, so there's a couple ways. I can just open with live server on the index.html. Okay, and what that's going to get me, let's make some room over here to bring our browser over. So that gets us a browser window that we can then open the console, do our thing in. Okay, so now we've got that running on port 5500. What we want to do is debug this app.js file. Rather than just throwing logs and seeing in the console here, we want to actually create a launch.json file. You can also just run and debug and choose web app Chrome. Okay, now it's created a launch.json file for us, but as we can see here, our live server is serving on port 5500, and the default configuration that VS Code creates is using 8080. So we just want to change that to 5500 and save our launch.json. Okay, and so now we've got this set up so we can launch Chrome against localhost. Okay, that's what we're going to want to choose, and I'll show you these other options in a moment here. We can also run current file. But for now, we want to go ahead and launch this configuration that we just did, which is going to pop open the browser. As you can see, it opened the browser again. So we can get rid of this one that we already had open. So it opened a browser for us automatically. And, oh, because I already have a breakpoint here, let's disable this breakpoint for a moment and let the app load completely, which just restart. So as you can see, once you start a debugging session, you get these controls up here, which you can move around, that allow you to restart, stop. So if I stop, we're done, the browser goes away. You can just come back over here and relaunch, okay? And so here's our basic little shopping cart. We have some items that get added to the cart, the prices, the quantity gets added, and we're getting $11.19.96, which if we look, we've got $9.99, quantity of 1, $29.99, quantity of 2, and $59.99, quantity of 1. So the tricky thing is we're getting the correct total here. I'm going to open this console too so we can see. Now, because we're in a debug session, you notice when you open DevTools, you also get the debugging here. Okay, so now to track down, since we're getting the correct math output, this could be really difficult to spot. Of course, we know it's a string, but we suspect that maybe this is what's going on. So for example, maybe on the web end, on the shopping cart, it's coercing correctly and we say, hey, no, the totals are right. But maybe this is coming from a database and an accounting program uses the same database tables, but it's a stricter program and the math isn't working. So what this can lead us to once we track this bug down, and what I'm going to do here is enable this breakpoint, but I want to show you if we edit this breakpoint, we can actually make it a conditional breakpoint. And this is a key point that, so what I've got here is a little expression that says, if the type of item.price equals string, then break. So we could, of course, let's just remove this and make it just a standard breakpoint. Okay, and we restart our application. So it's just going to pause there the first time through. All right, and that's fine. We want to look at what we've got going on here. We can watch certain variables. So of course we could watch total and add that. So right now our total is 0. Now up here in these controls, we can continue, we can step over, we can step into, and we can step out. Now, since this is looping here, what we want to do is let's step into it and we can see, okay, first pass through, it's added the total of our first item, $9.99.99. Okay, our return value is still undefined, and we can inspect further to see where we're at. So we've got, in fact, let's make this a little bit bigger here. So we're seeing the details of our object that we're currently paused on. So let's continue on. Okay, now we've gone to the mouse. We can see what we've got going on. It hasn't been added to the total yet, so let's continue. Okay, now we see that that's been added. Our total's correct. Price is $29.99. Okay, so as we keep going through, we step again, and now, oh look, why is there quotes here? So now we can spot that this is a string. We haven't added any console logs. There's nothing to clean up after the fact. We can just go and fix this bug. Or in this case, more likely, this is going to point us to, maybe these are user inputted. Now we need to go look at the dashboard code and put some validation in to ensure that when a user adds a new item, the price is a number, not a string. Okay, so this is the simple how you can step through and see every little thing. And of course you can speed through it by just continuing. It's going to run and it's going to do its thing. And we see our total has displayed over here. Now let's edit this breakpoint. Put that back on. Edit the breakpoint. If I right click on it, I can edit breakpoint. And let's put our expression back. Type of and we want to look at our, in this case, item.price, or it could be the quantity that you're having to track down. Maybe the quantities aren't functioning properly, but so item.price, and we want to make sure it equals a string. And if it does, then, so that what this will allow us to do is go through the code faster, and we can just hit enter to set that breakpoint. And now we can refresh our code, and you notice it went through laptop, mouse, our total's already 1059, but it paused on keyboard. So it's helping us spot that, oh yeah, there is a string in the number field. This is our bug. Even though it's coercing and appears to come out correctly here, we've now tracked down a sneaky type bug. And I know this is seemingly simple example, but the concept carries over and can help you track down very difficult to spot bugs. And this expression could be anything, any kind of condition that you're looking for, whatever you might suspect is going on. You can set a condition and let it pause for you. And in a large code base, this can be especially helpful because you could have to step through a lot of actions and try and inspect things. So by being able to add conditions in the areas that you suspect an issue, you can really track things down faster. Okay, so that shows how we can use the debugger. We looked at watching variables, everything, and we're even debugging in the front end. And of course we can step over and step into and do all of that in the browser here as well for the front end code. But what if we're not working on front end? So let's shut this debugging session down. We've touched on our conditional, but while we're in here talking about setting up the browser, setting up the debugger, let's look at other options. Okay, so run current file, Node.js instead of against the browser. So let's go back to our project here and let's close out app.js. We don't need it anymore. Our launch.json we're going to come back to, but for now, let's say we're working in cart.js. Okay, exact same file, exact same code as app.js. Okay, nothing substantially different here, other than the little bit of front end code to handle setting the price there. Okay, but so now we're working on the server side. We're going to debug a Node.js application rather than a front end application. And as you can see, I've already got our conditional breakpoint set here. We can just disable that for the moment. And what we want to do is now we want to debug cart.js. So we can open our debugger here, and in our dropdown, there's one thing, we can choose run current file, and it's run. We don't have any breakpoints, so in this case, it just logged out the price. And so on the server side, we might be looking and going, okay, well, we're getting the right total amount, so now what? So again, we can enable our conditional breakpoint with the same condition, type of item.price equals string, and run our code again. Okay, and so what's nice about this, I didn't have to do any configuration at all. I'm just running a Node.js app, easy peasy. Okay, so especially if you're doing simple little things, this is super handy. Now we can again step into and inspect things as we go. So let's restart this. Okay, and it's paused on our conditional breakpoint. So again, we see that we're at 10:59. Okay, well, why did it pause here? What are we paused on? Oh, we're paused on the keyboard again. And look, we can see that price has a string in that field. So we've identified our bug. We can now go figure out where to fix it. In this case, we can just fix our data, but odds are there's somewhere else that you need to fix, add some validation so that a string cannot end up in a field that should be a number. Okay, so that's the quick and easy. You can just run. Now, what we didn't get though by running way is, if you remember when I first opened the project up, we had these different selectors to choose different files. Okay, so let's go a little more advanced on our setup. Let's stop this, and we can add a configuration. Okay, so we can come in here. It's going to open our launch.json for us. Let's close down that terminal, give ourselves a little more room. And now you notice it's giving us a bunch of options. Okay, so for example, we might want to do Node.js and we want attach, or we might want launch. So in fact, let's choose launch, and notice it guessed app.js because that's what we had used before. We actually want to add cart.js. So I'm going to undo this and actually add it ourselves manually. Okay, so what you've got is a configurations array, and each configuration is just an object. Okay, so we can just put a comma here and come down and add the rest of our configuration. So let's actually go out to our example.json, and I want to talk about a few of these things because they're a little more than what you get just by default if you use the automatic configuration. So let's just copy all of these. In fact, let's just copy the whole file and come in here and replace what we've got here, and we'll talk through this. Now on the front end, one thing that I added in our custom configuration is source maps true. Now in this case we're not minifying anything, so it's not really that big a deal, but what this does is when we, let's save this file, and I'll show you what that does real quick. If we go into our debugger, so now you can see we have our whole list of files, and if you notice Node.js cart, Node.js cart async, launch against Chrome localhost, that's this title here. Okay, so the name field is what you're going to see in this menu when you set this up. So that can be very handy, especially in a large project. You just want to work on one particular file. You can just run that particular file. All right, now, so we actually want to start that one up. We're going to talk about source maps real quick. So let me get that browser back visible. It opened over here. Let's just drag it over here where we can see. And if we open DevTools, you notice we're on the sources panel. Now, if you had minified code, source maps is making it so that you can see the code as it's written. Okay, rather than seeing the jumbled minified code that is extremely difficult to read. Okay, so that is the source maps true option. Make some space here. That's the source maps true option right here in our configuration for the front end, which you don't get by default when we just chose to set it up. So now that's that. Let's talk about the Node.js setups. So for a Node.js file, the main thing is that we're giving it a name so that we get this popping up. So if we want to launch cart.js, which we already did, we have an async example that we'll get to next. But the one difference you'll notice here, we're just looking at the workspace folder, whereas for these, we're giving it a specific file. So in this case, we don't need to look for the JavaScript file because it's being launched, it's being run in the web server by this script tag here. So we don't want to point to a specific file here. We just want the workspace folder, and then it's going to pick it up because it attaches and connects with Chrome and gets it from there. Now, in a Node.js file, we want to tell it which file we're trying to look at. Okay, so our program that we want to look at is this file here. Okay, and you notice it's a different key also. So this web root, whereas for Node.js, it's program. Okay, some key little differences. Otherwise, type, we're telling it's Node instead of Chrome. Request is launch, as you saw, was from those menus. And these are just the same thing. Now the other one, skip files, if you had a complex project where you had node modules, this is just telling it to skip the node modules to keep things simplified so that you don't get a bunch of junk that you're not interested in looking at. Okay, and then the console is just telling it we're going to use the integrated terminal. All right, so that's our launch.json setup. So you've got a node setup in this object, okay, for cart.js. You've got a Chrome setup here. And you can clone this repository. I'll put a link in the description and get this example file that you can then drop into your VS Code configuration. Okay, so that wraps up setting up the debugger. So next, let's dive into a couple more tricky scenarios that we can more easily track down by using a debugger rather than good old console logs and messing up our code with a bunch of clutter that we have to clean later. We can just look for what we're after right at runtime. Okay, so let's close this up. Let's go to, we've got our debugger shut down. Great. I don't want that one anymore. Let's go to an async example. So let's launch cart.async and run. And you notice even without that file open, because we've specified, it's now going to open it up for me so we can look at what we're doing here. Now, essentially the same code. We have the same issue. We've got a string, but if you've ever tried to console log async code, chances are what you've gotten in the console is promise not resolved. Promise hasn't, so it tells you absolutely nothing because the console log's just logging out what you've grabbed, and a lot of times you're logging it out before the promise has resolved and come back with anything for you to look at. So then you're having to dig through your code and try and find a right spot to be able to log out and see what's happening with that promise. Maybe the promise isn't resolving, maybe that's the problem. But whereas in this case, we're able to run our code. Let's edit this and just get rid of our expression so that it's just a regular breakpoint and run it again. Okay, so now we're just paused on the first item so we can continue stepping through. So again, we can step into and look at, so total's not defined yet. Okay, that's okay. We're going to come back as we work through the loop and see, okay, now we're getting our mouse. We're going to add our mouse in. Okay, again, where it's pausing in the code, it's undefined, but that's okay. It'll come back around. It's total. So, and we can inspect it up here. We can keep stepping through and we can get to our issue ultimately, which could be any number of different things that you're looking at. But again, in async code, we're now able to step by step, every little bit, see what's going on. And that can be very difficult to do with console logs. So there you go. Another use case where using a debugger is going to make you a far more advanced developer. All right, so stop that, wrap up, and let's move into the call stack in our factorial file. Okay, so one thing we haven't touched on yet is inspecting the call stack. And when trying to debug recursive code, that can be very handy. Something you're certainly not going to get out of a console log. You can debug the call stack in the browser if it's front-end code as well. This, I just have a back-end file. So we're going to look at factorial, a classic recursive item. And this file, in fact, let's start off with, it could appear with a positive number, this code will work. We have a problem with our base case, but let's see how we can track that down. So we're going to go into our debugger again. We're going to launch factorial this time. Okay, so we've chosen factorial. We're going to start our debugger session. And now we're looking at this call stack category here. And as you can see, we've got one call on the stack. Now, as we continue, our n equals 5. Okay, so we can see now as we step through, I'm going to just kind of go continue. We've got another call added to the call stack because this is a recursive function. And as you can see, n is now 4. Okay, so we're going to keep going. 3, 2, 1, 0, and we're getting more calls on the call stack. Okay, so appears to be doing what it should be. Now I'm going to step into it so we can see it pop them off the stack. So I'm actually going to step into now. So as we continue, okay, so now we're starting to work our way back through that stack that we have built up. Return value is up to 1, n still at 0. Let's continue. Okay, now n is 1. Our return value is 2. Now n is 2. And as you can see, they're popping off the call stack. So if we continue on, 4, 24, 5 is 120, which is what should get returned from the factorial of 5. Okay, so at first glance, this appears to be working just fine. Okay, we'll continue on, let it finish, and if we open our debug console here, we can see that we got a correct console log of factorial of 5 is 120. All right, so now what we're going to look at is if we make this a negative number and run it again, what we're going to see is that, look at what n is doing. Negative 5, negative 6, negative 7. It's going up. And it's just going to keep going up. So we can click it a bunch of times and you notice that this is just growing and growing and growing. So we have an issue that doesn't handle negative numbers. And so what you'd get here is a stack overflow. So if you're just trying to console log, all you're going to get is a stack overflow every time. It's not going to help you identify that you're getting a stack overflow. You know, you're going to get a stack overflow message in the console potentially, but this allows us to do it in a controlled way where we're not burning up our processor trying to, you know, blast out through some broken method every time, a loop that doesn't have a correct condition. So being able to inspect the call stack and step through it. So, and we can do smaller again, we can step into it and go along the way. So obviously here we would need to add a case that handles what are we going to do if we have a negative number. All right, so that's being able to inspect the call stack. You've got some real pro tips there to track down extremely elusive bugs without the stress and, you know, I can't state enough how powerful learning to debug is in advancing as a developer. Okay, so just to wrap up here a little bit, you've got the tools. Wasn't that bad, was it? Couple items. Key points, conditional breakpoints, super useful, extremely valuable for tricky bugs that you're having a hard time finding, large code bases. The call stack for recursive code, extremely useful to be able to see what's going on there and inspect every step of the way. Each recursive call, and as it starts coming off the call stack, you can inspect what's going on. Something that is incredibly difficult to debug if you're not using a debugging tool. So with that, I hope this helps you out. Make sure you smash that like button along with all your tricky bugs and hit the subscribe button. We've got a bunch more content coming. This is the base setup that I'm going to use to start teaching a number of algorithms and data structures in JavaScript. A lot of times they're typically taught in Python, so I thought I'll do a series on that. And the first thing I figured I needed to do was show how to run code in a proper debugger session so that we can inspect what's going on as we compose our algorithms. So subscribe, like, go out and smash those bugs, stop beating on your head on the wall with console logs and cluttering your code and causing more work that you got to clean up. Level up with debugging. Thanks for watching. I'll see you in the next one.